Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Honors Geometry class. Today we're going to learn two lessons, guys. We're going to learn about the area of trapezoids, kites, and related figures. And the related figure that we're going to learn about is rhombus, because a rhombus is a kite, but a kite is not a rhombus, if you remember from our polygons. But we'll get to that. Okay, first off, yesterday we learned how to break down a trapezoid into a rectangle and two triangles. Today we're going to go ahead and formalize the area of a trapezoid, which is base 1 plus base 2 times height divided by 2, or 1/2 base 1 plus base 2 times height. Base 1, you can see it's labeled. Base 2 is labeled. It doesn't really matter who base 1 or base 2 is because of the commutative property. You can change the order of an addition problem, and it does not change the sum. Usually, I call base 1 the smaller one and base 2 the larger one, but again, it really, like 100%, does not matter. The height is the height. You're going to have to figure that out sometimes. For example, sometimes maybe I'll give you that this is 10, let's say. And then let's say that I tell you that from here to here is, 17. Okay? And then if this is an isosceles trapezoid, then from here to here is also, I may tell you that this whole entire base 2, let's just say, equals 21. Okay? So that means that from here to here would be 17, then that would be 2, and that would be 2. And then you use the Pythagorean theorem to find your height. So that could be a possibility. You know that, let me rephrase that. That is going to happen. Okay? It's not a matter of it's going to be a possibility. Sometimes they give you the height, sometimes they don't, and you have to calculate it. So again, I reiterate, remember your Pythagorean theorem, your Pythagorean triples, bless you, your special right triangles, and your trigonometry skills. Yeah, I don't know what trigonometry is, but trigonometry skills. SOHCAHTOA, sine, cosine, tangent. Okay, now, there's another way to find the area of a trapezoid, and it's by using what's called the median. We know what the median is. A median is a segment that bisects the two segments that it intersects with into equal halves, bisects it. And in order to find the median, just the median by itself, it's literally just base 1 plus base 2 divided by 2, or half of base 1 plus base 2. Using that median, I can find the area of a trapezoid if I just give you a median value and the height. The area of a trapezoid could be just the median value times the height. It's the same formula. Median equals 1/2 times base 1 plus base 2. The area of a trapezoid is 1/2 of base 1 plus base 2 times height. So I could either give you the base 1 and base 2, or I could give you a median. And you can find the area of a trapezoid that way. So again, the area of a trapezoid, 1/2 of base 1 plus base 2 times height, or the median value times height. Literally, it's that easy. Okay? So a couple examples. Number 1, given trapezoid WXYZ, the height is 7, the lower base is 18, and the upper base is 12. Find the area of WXYZ. Okay, this is pretty simple. They gave you everything. So area would equal base 1 plus base 2 times height divided by 2. 12 plus 18 is 30, divided by 2 is 15. 15 times 7, 70 and 35, so 105 units squared. Nice and simple. Sometimes they do give it to you nice and simple, and it's just a matter of remembering the formulas. Yes, sir. you could divide before you multiplied. As long as you remember order of operations, you had to do the inside of the parentheses first. So that's 30 times 7 divided by 2. If you wanted to go 30 times 7 is 210 divided by 2 is 105. I like to simplify, so I just divided 2 to both of these, making that 15, and then 15 times 7 is 105. Does that make sense, gentlemen? You got a question, my brother? Oh, okay. Okay. Easy peasy. Next. The area is 52. I want you to find x. Okay, plug in, guys. Area, remember, equals base 1 plus base 2 times height divided by 2. They gave you the area. That's 52. They gave you one of the bases. I'm going to call x base 1, or just x. Call it x. Plus the second base is 10 times the height of 8 divided by 2. At this point, now it's simple algebra. Multiply by 2. So I've got 104 equals, please remember to distribute here. That's where a lot of times my boys get messed up. 8x plus 80. Subtract 80 to both sides. That's going to give you 24 equals 8x divided by 8. And x equals 3 units. I didn't give you the units, so whenever I don't give you the units, you just put units. Because that could be feet, miles, inches, centimeters, millimeters, etc., yards. Does that make sense? The algebra makes sense? Promise? Talk to me, kid. You got it? Okay, my man. You sure, guys? All right. Next, they want you to find the median here, then find the area. Well, this should be pretty simple. The formula for the median is 1/2 of base 1 plus base 2. So in this case, it's going to be 1/2 of 14 plus 6 is 20. So the median equals 10. Now that I have the median, what's the area? Well, area also equals median times height. So 10 times 12, area would equal 120 units squared. Does that make sense? Nice and easy, right? Nice and easy. And that in a nutshell, my friends, are trapezoids. Any questions before we move on, my brothers? Yes, no, maybe kind of, sort of? Okay. Yes, sir. Okay, the question was, it's not always going to be that simple. Am I ever going to have to use Pythagorean theorem? You mean like this first example that I gave you? The answer is yes. Thank you very much, sir, for at least caring. Okay. Okay. Now we're going to learn about the area of kites and related figures. Luckily, the area of kites is actually a lot easier than you would anticipate. It's literally diagonal 1 times diagonal 2 divided by 2, or times 1/2. Literally. It's actually quite simple. The tough part here is sometimes you have to find the diagonal. Remember what happens with the diagonals of a kite. I'm sure some of you don't remember, so I'm going to reiterate it. They do not bisect each other. No. No, they do not bisect each other. Look at the figure. The longer diagonal is a perpendicular bisector to the shorter diagonal. That does not mean they are perpendicular bisectors of each other. It means that the longer diagonal is a perpendicular bisector to the shorter diagonal. Okay? And remember that in a kite, this guy will be congruent to this guy, and this guy will be congruent to that guy. Got to remember your kite facts. Now, rhombus. We have learned before that a rhombus is like a parallelogram and like a rectangle, and that you find the area of a rhombus by doing base times height. A lot of times, most of the time, they are not going to do that for you. Okay? Instead, you're going to use the exact same formula as the kite. Diagonal 1 times diagonal 2 divided by 2. Now, here, the diagonals of a rhombus, they are perpendicular bisectors of each other. So that, and then that. Okay? They are perpendicular bisectors of each other. You with me here? Okay. So the area of both a kite and a rhombus is 1/2 of diameter 1 times diameter 2. For example, find the area of kite ABCD if BD is 14 and AC is 9. Nice and easy. It's 1/2 of 14 times 9, literally. It's that simple. So this is divided by 2/7, so this is 63 units squared. 63 units squared. I'm looking for area, correct? So area would always be units squared. Okay? Does that make sense, guys? Okay. Okay. Next. The area of a rhombus, I want you to find the area of a rhombus whose perimeter is 20 and whose longer diagonal is 8. Okay. So the perimeter is 20. So that means all of the sides are 5. The longer diagonal is 8. So if this piece is 4, that means that this piece is 4. Okay? So what kind of a triangle is formed here? 3, 4, 5. So if that's 3, that's 3. So 1/2 of 8 times 6, that equals 24 units squared. It's that simple. Not bad, right? Okay. Thank you very much. Hope you learned a lot, and you have a great day.